Welcome back to my YouTube channel. Today I'm talking about the core function in R. The core function calculates the correlation coefficient between two vectors, the columns in the data frame, or the columns between two data frames. We'll look at an example of each. By default, the correlation coefficient is calculated as the Pearson correlation coefficient, but you can also use Kendall and Spearman. And if you have missing data, you can also modify how that's treated in the code. Okay, I'm going to start by making two vectors. X equal a standard normal with 100 observations. Y is going to be a function of x plus random noise with mean 0, standard deviation 1. I need 100 of them. Okay, so I'm going to do the core function, x comma y. Or if you want to be very explicit, x equal x and y equal y. And we get a correlation. More specifically, a correlation coefficient. Okay, and now if we enter a data frame, we only need to specify x, so x equal iris, and I'm only going to take the first 4 columns, get the last one categorical, and it will not really be appropriate in this calculation. Okay, so here we are. As expected, you'll see down the diagonal, we have all ones with the variables are compared with themselves, and we also have the variable compared with each other, steeple length, steeple width, negative 0.1, so on. You'll notice we get the same thing here, that they're inverted, so we're doing the same comparison, steeple width, steeple length, get the same answer. So you really don't need to focus on the bottom or the top, depending on your preference. If we want to compare a column between two data frames, we do that very similarly. And I'm not going to be too creative here, so I'm just going to reuse the iris data frame, but I'm going to tell the function that these are two separate data frames. The first 2 columns of the iris data set is x, and the next 2 columns will be y. You might think we'd get a similar output, but here we are only comparing the columns of x to the columns of y, so we're comparing the steeple length and width to the petal length and width, and we get those correlations. So you get different outputs depending on your need, and you don't get the redundant steeple length correlated with steeple length. Okay, and as always, I have another example on my website, stats4r.com, and that's the end of the video. Thank you for watching.